What we are really doing when we talk about sample size, we're really trying to find out if we have enough statistical power to avoid a type 1 and a type 2 error. Now, we call it sample size, but it's really power analysis.
Power? I thought this was about strength training. This is about power analysis in your quantitative study. Benvenuti scholars, I'm Dr. Markette, and I'm here to help you graduate with your doctorate. Today, I'm joined by my friend and scholar, Dr. Landry, whom you heard at the beginning of this video to unpack the terms and reasoning behind using the online calculator called G-Power. That helps you with the correct sample size for your quantitative study. I provided a list of timestamps for each section of this video in the description box below, but I really encourage you to watch all the way through because you may learn some nuances that may have been fuzzy for you before. Let's roll.
I like to alliterate with the 3 A's, the all, the available, and the actual. And I have things called the 3 R's, random, representative, and reproducible. So what we are doing with a sample is we're trying to infer from the very large by taking a representative sample. Well, let me give you an example. The learner wanted to know something about the members of a call center. You know, this is where you call in and people answer your question or whatever. Now, the actual fact, there was something like 4,000 people involved in the call center. Well, you can't work with 4,000 people. So then what she did is she said, okay, I'm going to now focus on the call center workers in my company. And there's 400 of them. And that's still kind of large. And from that, now she's going to draw a random sample from the 400 to her actual. So the question she had was, how many do I really need?
Knowing the answer to this question is necessary, not only for writing your prospectus and proposal, but also to identify whether your study is feasible. In other words, whether you realistically have availability to the number of people you will need for your quantitative study. To help you understand feasibility a bit more, check out this video. G-Power is one of the most common online power analysis calculators to determine the minimum number of needed participants, and will let you know in seconds the answer to this very important question. This next section will show you exactly where to find the G-Power calculator and how to use it. First, enter G-Power in your search engine. Then, choose the first entry from the University of Dusseldorf. Once there, scroll down to the download section and choose whichever download link matches your computer, Windows or Mac. After a few minutes, you'll be able to open this power analysis calculator. And this is what the G-Power analysis calculator will look like. Before we do the calculations though, it is important to understand what type 1 and type 2 errors are, as Dr. Landry alluded to in the beginning of this video.
So the goal of power analysis is to minimize type 1 and type 2 errors by establishing the minimum number of participants that you need for your quantitative study. For this discussion, there are 4 possible outcomes of quantitative tests. The first is a true positive. A true positive would be a pregnancy test that shows positive and the woman is actually pregnant. The other possibility is a true negative. A true negative would be when the woman's pregnancy test shows negative and she is not pregnant. However, just like this athlete, there could be a fail. And just as Pinocchio's nose grows with an untruth, sometimes the test comes back as a false positive or a false negative. A false positive is the common term for what scholars call a type 1 error. The result is positive, but it is incorrect. Here, the apology is something positive, and Joey doesn't mean it, so it is a false positive. The other fail is the false negative, which scholars call a type 2 error. The result is negative, but is actually not negative. In this scenario, this guy denies the truth, which would save everyone heartache. Hopefully, type 1 and type 2 errors are a bit clearer now. Back to Dr. Landry.
Both of these are bad. You want the truth. Our primary goal is to understand the whole. We want to understand the whole general population, but we are reliable only to the extent that the target population reflects the general population. And for that, we have a thing called a margin of error that gives us the degree of reliability that what we are looking at reflects the total. So between these two fences, we have our usable data. The type 1, now the type 1 is expressed here as alpha, and alpha at 0.05. 5% of the time, you're happy to accept the false positive. And 20% of the time, in other words, that 80 minus the 100 is the amount of false negative.
So let's go back to G-Power and apply this understanding of type 1 and type 2 errors. Let's take a tour of this power analysis calculator called G-Power so that you better understand the terms. Test family, statistical test, type of power analysis. It is important to note that this calculation should be done twice, a priori and post hoc. Then a left-hand box which input parameters, which you will enter, and a right-hand box with output parameters, which will automatically populate for you when you click the calculate button at the bottom of the screen. Tails, effect size.
If you click on determine effect size, you can fill in the pop-up to the right, or you can follow Cohen's suggestions depending on the test that you choose. Tell us how that works, Dr. Landry.
You could use the estimate that's provided by Cohen, and that's dependent upon the type of test we're doing. Let's say we're doing a t-test. If you think the difference is going to be small, use 0.1. If it's medium, whatever that means to you, 0.3, large, 0.5. The type of effect that you want to plug in is dependent upon the test you're doing. And again, as effect goes down, the sample size goes up.
Alpha error probability, power beta error probability. When we enter all of this information and click calculate for the results, it is called running a power analysis.
Here you can see the results for a one-tailed correlation point by serial test. It shows that the minimal number of participants should be 64 people. Now let's switch from one to two-tailed for the same correlation point by serial test to see the difference in the required minimum participant number. When we hit calculate this time, the number changes from 64 to 82. Pretty big jump. Here are the results side by side.
So now you should feel a lot more comfortable with the terms and reasoning behind running a power analysis using the analysis calculator called G-Power from the University of Düsseldorf. A special thanks to my friend and colleague Dr. Victor Landry and Ruth Madrid from the gym. Please join the community of scholars on this channel, subscribe and turn on the notifications, and let me help you get to graduation.